Now, let's solve an indexing problem together. When we have an indexing problem, we have to read the question very carefully. Okay, now let's do that. How to read a question? Now, the question says that suppose there is a data file which consists of 30,000 employee records. Okay, and the table name is employees. It has SSN, name, jobs, title, salary, etc. Each record is of how much size? 150 bytes. The database use is unspanned, okay, and the records are ordered by SSN. The disk block size is 512 bytes. Given this question, we have to pick up the capital B, capital R. We need to calculate BFR. We need to pick up small r. Okay. Now we know that BFR is equal to capital B divided by capital R. So now this is the given data. This is the given data. You will be given with the block size, you will be given with the record size, you will be given with the total number of records. Now you need to find out BFR, okay, which will give you the number of records that can be stored in each block. So we have a block of size 512. In this, how many records can be stored is calculated by capital B divided by capital R. Now, once you have this, you can easily calculate small r. The small r is given by this number, 30,000. This is the size of the database. Okay, now once we have the BFR, we can calculate the small b. Okay, so if you are understanding, this is what we have to calculate. Okay, this is what we have to calculate. And for calculating these two things, we need to know this, and we need to know this. Are we understanding? So these will be given in the question itself. You have to pick it up very carefully. Okay. So now reading the question again to pick up the capital B, capital R, and small r. Suppose a database file consists of 30,000 employee records. How many records are there? 30,000. So small r is equal to 30,000. And each record is of 150 bytes long. So the capital R is 150. Okay, capital R is 150. The block size is 512. Okay, so you need to write this. Okay, you need to write this carefully. Now, the first question says, how many disk blocks are needed to store employee database? Okay, now, in order to find out that how many blocks are needed to store these 30,000 records, we first need to understand how many records can be stored in 512. Then we can easily find out this. So, the number of records per block is given by BFR, which is equal to capital B divided by capital R, which is equal to 512 given in the question divided by 150 again given in the question, which is nothing but 3 point something, like for example, like 512 divided by 150 three times, and then you get it. But we are being questioned that the DBM is used unspanned, means we cannot have this half record stored in some place, another half remaining of this stored in another place. So we have to eliminate this one. So that's why we use floor function applied on this. So it means we can have three records in each block. Now once we have this three records BFR, we can easily find out that how many blocks are needed to store these many records, which is given by small b is equal to small r divided by BFR. BFR we calculated, small r we have it already. So we are going to now find out the number of blocks that are needed to store, number of disk blocks that are needed to store the employee database file, which is nothing but B. So we are going to say 30,000 given in the question divided by 3, what we have just calculated. So it is going to be how much? 10,000 blocks are needed. So how many blocks are needed? We need 10,000 blocks. So one question is solved. Okay, now another question. On an average, how many block reads? Now, whenever we say block read, it means we are doing a search operation. Now, search operation, okay, this is something different from apart from the question. Okay, now whenever you do a search, the search can be linear search, okay, or it can be a binary search. If it is mentioned in the question to use linear search, you can pick up the formula b divided by 2. If it is specified or mentioned in the question to use a binary search, we have a formula log to the base 2 of b. But you see, it is not given directly in the question. So we have to be very careful to use linear or binary. Now, here, this piece of information is going to help you with the searching. This part of the question is going to help you with the searching. Now, what does it say? It says that records, okay, records are ordered by SSN. Now you see here, we have SSN, right? We have SSN. So I'm going to use a binary search. Sorry, I'm going to use a binary search. Okay. So, oops. Let me write down the formula for binary search again. Oops, what's happening? I want eraser. Okay. And let's write down binary search. Binary search. Binary search formula, we know it is log 2, log base 2 to the b. We have the value for b already. So it's going to be log 2, log base 2 to 10,000. This is the value of b that we just calculated here, no? So it's like if you just calculate it, it is coming around 14. So we need to have 14 block access if it is going to be SSN. Okay. Okay, if SSN is this one, it is ordered by SSN. So whenever we have ordered SSN, whenever the table is ordered with a particular key on which the search is being asked, apply the binary search. Now, I will tell you the logic why we are doing like this. You see, students, if the table is arranged or ordered with SSN, it means they are primary, yeah, SSN is a primary key. It means it is the values are arranged in an ascending order. They are ordered. Okay, they are ordered and they are non-repeating. So when I have, for example, all the employees arrange in an order, it is easier for me to search. So I can apply the binary search, right? I can apply the binary search. So I have less number of, searches required. But if the field, for example, if we are trying to find out a specific employee with the name search, okay, so the name is not, the table is not ordered with the name field. Hence, it is difficult to find out. So I have to search employee with the name for the first one, for the second one, for the third one, and so on. So it is going to be a linear search. Whenever we have linear search, we have average access by given by b divided by 2. For example, let us take an example of a student database. If I want to find out a student by name Sarah, okay, and I don't know her academic ID, so what do I have to do? I have to search the whole database for all the students by her name, one by one, right? So this is the linear search. Now if I have an academic ID, it is very easy for me. I can just find out the academic ID, if I can find out the academic ID with her academic ID serial number, I can find out in which year she belongs to and in which section she belongs to. So this is like a binary search. I go directly to that particular year and the section, and then I can find Sarah with her academic ID. So whenever we have to search with ordered field, we apply binary search. Whenever we try to search with an unordered key, we use binary linear search. Are you understanding? And this is a formula for the linear search, and this is a formula for the binary search. Hence we got our second question solved. Now let us understand the third question. Suppose we create index on employee. Okay, now we are talking about index on employee. Okay, so whenever we have an index key, we have a field name. So it is going to be SSN. SSN, okay. The field size is 10 bytes, okay. The pointer size is 10 bytes. Okay, so how much SSN size is going to be now? 20 bytes. So this is important. Now our capital R became 20. In the question earlier, it was how much? Why is it not moving? Okay. Oops. I want to move. So I want to move, scroll up. Okay. Okay. Wait a second, please. Now in the question, okay, what happened? Why is it stuck? File. I want to save this. Yeah, now it is moving. Oh my God. Oh my God, what happened? Okay, so now here capital R was 150. Okay, because it was having the size of SSN, name and job and title and salary. Now we only want to make an index on SSN, and it is telling us that the size of SSN is 10 and the pointer is 10. So it became only 20, right? So here our new R for this question number 3 is 20. Okay. Done. How many disk blocks will be required to store the index file? For the index file, how many uh, what do you say? How many blocks are needed? So now what we have here is we this one was for the whole table. Okay, this one was for the whole table, right? So now we have to find out the new BFR. Okay, so let me write down BFR is equal to capital B divided by capital R. So BFR 512 divided by how much? 20. Okay, now you calculate and tell me how much is it? Calculate and tell me. So almost like 25. Okay, and because we have to use, we don't want to use the point values, so we are just taking the floor of it. So 25. Okay, so now our BFR is 25. Okay, how many blocks are needed? Now we need to calculate the small b. Small b is nothing but R divided by BFR. Okay, BFR. So R is how much? R was how much? uh just let me. So R we calculated it to be 10,000 divided by 25, which is equal to 400 blocks. So what does this mean? Now when I have to store the index file only to store SSN, okay, with its field size and the pointer size, for storing this, index, I need additional 400 bytes. Okay. So did you understood why is it smaller? Because in this place, it is it is taking how much size, how many blocks? 10,000 blocks, because we want to store the whole table with all the fields. But here we are just storing one index file. Okay, one index file with only one SSN field. Okay, so it is going to require only 400 blocks. Now let us solve the fourth question. The fourth question is asking, is it a primary index or a secondary index or clustering index? Because we have the table ordered on SSN, okay, and we know that SSN is the key field. These two pieces of information is given in the question itself. You see here, it says here records are ordered by SSN, which is a key field. Now whenever we have an index made on the key field, then it means it is a primary index.